Hello everyone. In this video session, we are going to discuss about the basics of threads and the various multi-threading models. The first thing is we will now discuss what is meant by a thread. A thread is a single sequential flow of control within a program. It is the basic unit of CPU utilization. So this is the definition, the formal definition of what a thread is. Now, as we move further, we will be able to reason out the second point, that is, why is thread stated as the basic unit of CPU utilization. So let's move further. Before we move on to the benefits, let's look at this diagram where we have a single and a multi-threaded process represented diagrammatically. If you look at the first diagram, the single-threaded process, what we observe here is we have a single thread of control, and the single thread of control has got its own code, data, files, stack, and registers. So we have in this process, we have only one thread of control, hence it is stated as a single threaded process. But now when we move on to the concept of multi-threading, multi-threaded process, here we have, according to this diagram, we have three threads of control. And if you observe the block above it, we are able to observe that registers and stack are given uniquely for every thread, whereas the code, data, and files are being shared among the three threads of control. The meaning here is these three threads belong to the same process. Hence, they can share the code, data, and files, whereas they will have their own register step and stack. So this is what makes a thread different from a process, and that is the reason why we call a thread as a lightweight process, whereas an ordinary process as a heavyweight process. Now moving on to the various benefits of using threads in programming, there are four benefits. The first one is responsiveness, the second one is resource sharing, the third one is economy, and the fourth one is scalability. Now let's see what is meant by responsiveness. Now, responsiveness is nothing but the thread which is currently executing will not be made to block till it gets the response for the request which it had sent. Instead, the thread will be continuing with its execution even if part of the process is blocked, especially for user interfaces. The second advantage is resource sharing. Now, when we have already seen in the previous diagram which we saw, where the code, data, and files are being shared among all the three threads that belong to the same process. Economy. Therefore, because of this resource sharing concept, definitely threads are cheaper to create than processes, and thread switching will cost lower overhead than context switching. And finally, the last benefit is scalability. Process can take advantage of the multiprocessor architecture. Because of the multiprocessor architecture, the scalability advantage is taken into account. So these are the four benefits of any multi-threaded programming language or any multi-threaded programming platform. Now let's move on to the different types of threads. We have two different types of threads, namely the user threads and the kernel threads. Now, what is meant by a user thread? If your thread is managed at the user interface, user level library, then it is called as user threads. Whereas kernel threads will be supported by the kernel. And what is listed out here is these are the examples of user level threads, and these are the examples of kernel level threads. So kernel level threads, all the threads virtually all general purpose operating systems, including Windows, Solaris, Linux, etc., Mac OS, will have kernel threads. So this is the two different types of threads, user and kernel. Now let's move on to the various multi-threading models. We have three different multi-threading models, namely many-to-one, one-to-one, many-to-many. Let's now see them one by one. First, let's take the many-to-one model. In the many-to-one model, as you observe in the diagrammatic representation, we have a kernel thread mapped onto several user threads. See, user threads are represented like this, and kernel threads are represented with a circle with a K inside. Now, this many-to-one model depicts that many user threads are mapped onto one kernel thread. So this is the concept behind many-to-one model. So what happens is, even if one thread gets blocked, it will cause all the remaining threads to get blocked. So multiple threads may not run in parallel on multi-core system because only one may be in the kernel at any time. So we will not be able to support parallel execution of multiple threads. And we have very few systems which still use this many-to-one model. Examples of those systems are the Solaris operating system and GeoEnit portable system, which uses the many-to-one model. Now we'll move on to the next multi-threading model, which is the one-to-one model. Now, if you observe in the diagram, we are able to see that in the one-to-one model, for every user thread, we have one kernel thread mapped to it. So that is the reason why it is called as one-to-one. Now, whenever there is a need for creating a user thread, a kernel thread also has to be created. This is the concept. So what happens is, you will have overhead because of the increased number of kernel threads being created because of the creation of a user level thread. Examples of operating systems that use the one-to-one model is given here. Windows, Linux, and Solaris use this model. Now we'll move on to the third model, which is the many-to-many model. In the many-to-many model, as you observe, we have many user threads mapped onto many kernel threads. And always, please remember, it's always mapped onto a sufficient number of kernel threads. So the Solaris and Windows make use of this many-to-many model. So what is the advantage of this many-to-many model? We will see from the two-level model that we are going to discuss now. In the two-level model, we are having two levels. One is, this is the many-to-many, and this is the one-to-one. Many-to-many combined with one-to-one, I've got a two-level model. Now, this is very similar to the many-to-many model, except that it allows a user thread to be bound to a kernel thread. So here, once the mapping takes place, if one user thread is mapped onto, or if you say two or more user threads are mapped onto one kernel thread, that mapping will be bound. You cannot change it. So this is the two-level model. So with this, we have now completed what the basics of threads and what are the various multi-threading models in detail. So in our next video, we will see what are the various issues that are available with the